Good day, academians. Welcome to Study with Mr. M, known as the Maths and Science Academy. Of course, continuation from scenario number 4 to scenario number 5. Let's increase the heat. Now, what you'll see here is all the scenarios in one scenario, and I'll show you how. Remember the scenario where we said that the ball, if it's thrown from the same height and caught at the same height or whatever, but we also said that the ball at the same height that it was thrown at, it has the same velocity but in the opposite direction. We spoke about the ball having maximum height, and at the maximum height, what is the velocity? Is 0. We spoke about a ball being thrown and not caught at all until it reaches the ground. We spoke about a ball being thrown from this point to the ground, from a height to the ground, and we also spoke about a ball being released from the height to the ground. That is all the scenarios that we've done so far. And I'm just trying to prove to you that it works. It works. Physics works. Guys, physics works. Now, I don't want to do a lot of stuff. I just want us to continue with this one. Now, here is what we call... Now, a lot of teachers like to do the scenario where a ball bounces, a ball is thrown and bounces once. And then they do a scenario where a ball bounces twice. And I'm thinking, why would you do a ball bouncing twice? Because if they understand that the ball will bounce like this, like this, like this, like this, until it stays flat on the ground. If they understand only one bounce, they'll understand all the bounces. I'm just thinking it like that because maybe I trust you that much, guys, right? Of course, here, I've done something. I've drawn the graphs because the graphs here, they'll take time. And I know, guys, I don't want to make long videos because I'm seeing that that's not a good way of teaching, right? They make long videos. I make long videos for no reason sometimes because I just yap. So you see right now I'm even yapping. Let's continue. Right now, a ball is thrown and bounces once. Now, the initial velocity, of course, is not 0. Why is it not 0? Because the ball is what? It is thrown. It is projected. It is given an initial velocity, and then the only force acting on it after that is what? Is gravitational force, meaning the ball is in what? Is in free fall. Did I just go back to introduction of VPM? So if you skip to the introduction of VPM, it was solved. You will regret skipping the introduction because those who were there on that 11-minute video, they know what I'm talking about. Right? Now, let's continue. V initial. Hey. V initial. Hey. V initial is greater than 0. V max always is equal to 0. But V initial and V at C, which is the same point as A, will be the same but in the opposite direction. Now I want us to remember this. I said to you, always take the first direction as what? As positive. What is the first direction? The first direction is up, so we must take up as what? As positive. Are we following? Of course we are following. You can't be here if you're not following me. Haibo. I'm just playing. Right? Now, what will happen is that when the ball goes up and is not caught, it reaches the ground. It is in contact with the ground for some time. I didn't show that in some textbooks. You may see some textbooks maybe saying this, then say this one, then they show this one, meaning that here there's contact time, right? There's time where the ball is on the ground, stays with the ground for some time. Of course, in real life, you do not see that, but it does happen, right? So let's continue. Now, the ball will be in contact with the ground, then it will go up again. It reaches maximum velocity, but it comes back to the same point it was projected from, that it bounced from. We can think of it like that. And then now we are back to scenario number 1, meaning the velocity at F will be the same velocity as D, but in the opposite direction. So if the velocity that it left the ground with is maybe 15, let's stop using 15. If the velocity that it left the ground with is 5, it means that the velocity at F should be the same as velocity of D, and it should be negative 5 meters per second. They are the same velocities, but in the opposite direction. Is that scenario number 1? It is scenario number 1. And now you see that you have to learn all these scenarios because if they show up in an exam, there's no way you are failing the scenario. that you already know, that I've already taught, right? So you see, the same principles apply all round. You have to analyze that, okay, here in this portion, there's scenario number 1, right? Here, this portion is scenario number 2. This portion is scenario number 3 and 4, right? And this whole part, we call it scenario number 5. You don't have to know the scenarios by name. You just have to know the principles that we follow in each and every scenario, right? And those scenarios are there to make you understand. Okay, let me stop yapping. But they're there to make you understand, guys. I'm just joking. They're there to make you understand, because I can't make you understand everything. Now you see that we have Vmax 1 and we have Vmax 2. Because the ball reaches maximum height how many times? 2 times. Oh, I'm afraid. 2 times. That's no time, but it's fine. Right? Now, what you must understand is that this is not complex. So if you were to do the same thing over here, it would happen again. If you were to say that the ball then goes up again, then you say, the ball goes up maybe again, and then does this. This is going to happen again. Let's say A, B, C, F, G, H. Right? Now, this here will be another Vmax number 3. The maximum velocity. What is the velocity at maximum height? The maximum velocity is 0 meters per second. Right? What is the speed at h? The speed at h will be the same as the negative speed that initial at f, right? Because it will be the same scenario number 1, just it happens differently. Now what you must take note is that the ball will strike the ground with another velocity and leave the ground with another velocity. So it doesn't mean that if I strike the ground with -5, I'll leave the ground at 5. No, it doesn't work like that. It means that if I leave the ground with 5 and I come back to the same point, I'll come back to that same point with 5, but in the opposite direction, not the negative direction, the opposite direction. So I hope everyone understands that part, and I hope I've done justice to that part. I think this is a great scenario, man. This is a great scenario. There's no way to do this. That's why I'm saying, if I wanted to do this, I could have added another bounce and said this scenario number 6, which you just waste our time. Right? Because scenario number 6 will be a balloon, and that will be our last scenario. Right? Now, of course, I said to you, the delta y always takes the position, the direction, or the motion's shape. Now, what does the graph do? If we take the height, if we take the ground as a reference point, this is what it's going to look like, right? Because we are going to go up, reach maximum height, go down to the ground, which is the 0 point, if I take the ground as a reference point, right? Because the displacement between the ground and the ball will be 0 at that point. And then I will go back again up, reach maximum height, and then go back to the ground. If it was another bounce, it would do the same thing over there. You'd say the same thing. But if you take the height as 0 reference, the height where it starts from, when I speak about height, it is where it starts from, right? You will start from here. Then you go all the way, just like scenario number 2, you come back, you are not caught, then you go in the negative direction, right? Because we're taking the height as the maximum, not the height as maximum, we're taking the height as reference point. Then it's going to come again, then it comes back to that certain point or certain height it was. You see, it does not take the ground as a reference point, because here the displacement at that point will not be 0, but we know that displacement over here is 0, right? So if you take, they will tell you in an exam which one to take as a 0 reference point, and as you keep doing the questions, you'll understand. And you see, I've labeled the A, B, C, E, F, G, F over here as I've labeled over here. I expect these scenarios to be on your book. When you study with the scenarios next to you. You pick the scenario that you think is suitable and you work it out. There will be a point when I start doing past paper. This I'm not speaking about just practice. When you start to say, I'm exposing myself to past papers, you have to expose yourself to exam conditions. Why? Because in an exam, there will be no scenario next to you. You have to know the scenario. Meaning, if you keep practicing, You won't even need to put that scenario next to you by the time you do pass papers. Do you get me? Do you get me? Of course you get me, dog. You wouldn't be here if you didn't get me. Of course. Let's continue. Now, I'm loving VPM. I'm loving VPM. I won't lie to you. We said that the velocity versus time graph is a straight line graph. Now, let's take this scenario again. Let's explain it over again. Come here, Wena. Come here. Sharp. Now, what is going to happen? The velocity is going to decrease. Why? Because the ball is going up. It's going to decrease until when, man? It's going to decrease until it reaches maximum height. At maximum height, what is the velocity? It is 0, which is t1. And then it's going to go up again. It's going to go down in the opposite direction, and then it strikes the ground. When it strikes the ground, it must be in contact with the ground. Nothing is happening there. And then it leaves the ground. But you can't then say it leaves the ground again here. Right? So you have to label your graph that here, this is A. This is B, maximum height, right? So let's label it A, B, C, right? D, E, F, right? Now, we can say A. B is the maximum height. The point at which it strikes the ground, it is D. So you should show that as D. But as I said that if you have something like this, just because it strikes the ground with a certain velocity doesn't mean it leaves with it. Right? It may strike the ground with a velocity of -5 meters per second, meaning it's downwards. Right? And then it leaves the ground with a velocity of 7 or a velocity of 3 positive. Why is it 3? Because it's going upwards. So you have to show the dotted lines and show that it's no longer going up, down. It's going in the it starts with a velocity in the positive direction that we chose, which is upward. Now you see here the velocity is less because as the ball collides with the floor, it loses energy. And as you know that energy or kinetic energy is what is 1/2 mv squared. So suppose that the mass stays the same. These two are what? Are directly proportional. So EK is directly proportional to V. It means that if I decrease the velocity, if I lose energy, I will lose my velocity. Right? I will decrease in terms of velocity. You see why I started with that topic? Because I know what I'm doing. But it's fine. It's fine. You see here now the velocity that we come with is much lesser than where it started from. This one is higher, this one is lesser. Right? Now that's what you must look at. Then it's going to do the same thing again. It's going to do the same thing because now it leaves the ground. Right? You need to show that it was in the ground for this time. Right? It was in contact with the ground during this time. Right? This is the contact time. Then what is going to happen is that the ball is going to do the same thing it does because it's going up. Right? From here. This is now D. This is now D. Right? We should say that this is D1 when it strikes the ground. Right? This is D2 when it leaves the ground. Let's say it's D2 when it leaves the ground. D2 will be upwards. If you get me, it will be going upward towards E. Right? Look at here. Look at here. It's going upwards towards E. I said to you, when the ball goes up, what does the velocity do? It decreases until it reaches maximum height. And that happens over here. The velocity decreases until it reaches maximum height. And then it goes again in the opposite direction. But I want you to look at something. Right? I want you to look at something. I said to you, in this scenario, this part here, this part, where's this thing? Oh, yeah. This part here is scenario number 2 because we said that this is the scenario number 2 where the ball goes up and is not caught at all. One thing we said that is that the time it takes from here to here is not the time it takes from here to here. Right? So these two triangles will not be the same in terms of area. Right? And what is area for a velocity time graph? It is what? It is displacement. But we use the area of a triangle so that we don't get wrong in an exam because they want it like this. And we know we said it's 1/2 VT. Right? But if you look at here, this other part, this is now scenario number 1. And you said in scenario number 1, because the same velocity that it leaves with would be the same velocity that it strikes the ground with, but in the opposite direction, so that those two triangles should have the same area. So those two triangles should have the same area, meaning to go from T3 to T4 will be the same thing to go from T4 to T5. Just the same thing, right? See, the scenarios are repeating themselves, just that now you have two scenarios or three scenarios in one scenario, if you get me, right? So now you have many scenarios compiled in just one question, if you get it correctly. Now, you just need to know that if they told you maybe that the velocity here is 5, we need to show 5, not 15. Yeah? Then they ask you, what is the velocity maybe? Because here it reaches maximum height again, right? And what is that part? That part is E. This is E. Then it goes down again to the ground, and then it strikes the ground again with F. They say maybe find the velocity at F. You already know that the velocity at D should be the same velocity as F, but in the opposite direction. So over here, I should have negative F, negative 5. Just like that. That's how you know. But if you had a velocity of 6 over here, you can't then have negative 6 over here. It doesn't work like that because the ball does not strike the ground at the same, is not caught or is not the same point that it was thrown from. It only works in symmetry. If the ball is going from the same point, coming back to the same point. As you see over here, the ball comes from the same, another height, then it goes back to another height. It passes the point at which it was thrown from. So we can't equate the velocity. They are not the same. Right, so this velocity should be quite large, or maybe you'll have negative 12 rather, right? Let me not say 12 because people will think you double the velocity. No, they say negative 8, right? That's just that, right? Now, as I said, everything still applies. The gradient is to acceleration, because acceleration is also change in v over change in time. That's just that. Oh, my friend, I showed you this and I told you. I said to you, we'll do all the scenarios and my brother here will remain the same. And he's still remaining the same after everything we've done. Look at this. What is he doing? My brother here, what is he doing? We chose the upward as positive, meaning that my down is negative. What is my 9,8 direction? It is always meters per second squared. Where? Downwards. Downwards, right? But now, if I chose downwards as negative, I must put that negative over here. So I must draw it in the negative part, and I just show that, okay, it is negative, and the acceleration is just constant because it's the acceleration due to gravity. Of course, I've shown you so many scenarios, guys. I'm sure now VPM is starting to grow on you. I'm sure VPM is starting to grow on you. I know, guys. It's hard. It's challenging. I know. I don't want to act too smart or anything, or smart to begin with. I'm not even halfway there, but I believe that with practice it gets better. It does get better, guys. So let's just keep pushing. Let's keep pushing, and these scenarios will be very easy when we do past papers, right? So can you allow me to do the last scenario? I'll see you on the last scenario.